Okay, in this video I'm going to talk a little bit about boards, how to connect the boards to your transmitter or to your receiver, whether you have S-Bus, which is Futaba, or a serial connection like Jetty or JR, or for example Spectrum, or even PPM for those of you who have a radio that runs off of a PPM signal. I'm going to talk also a little bit about how to set up your board, how to flash your board using Betaflight, and so that should do it. So let's start with the boards themselves. So I have here an F3. This is a board made by Foxier. It's very inexpensive, $19.95 in the United States, $20. There's different kinds of F3 boards. There's the SPF3. There's one made by Emax. I mean, there's all different kinds, and they all vary a little bit in their layout and configuration, but for the most part, they're all very similar. So as you can see, this board comes with all these pigtails and white connectors. A lot of these connectors trace back to a certain function within the board. I personally don't like to use the wires off of the connectors because the connectors are made out of plastic. And you know, over time with crashes and stuff like that, they can break. Also, a lot of the times these connectors stick out of the sides of the frame. So something I don't like, I prefer to keep the wires inside the frame. So I normally get rid of all these wires. And again, most of these connectors also can be accessed through a tab on the board itself. So first, you got to determine what type of radio transmitter system you have. So if you have a Futaba S-Bus, I believe Tyrannus works off of S-Bus as well, although I might be wrong on that one. But as long as it's S-Bus or a UDI type protocol or signal, you can connect your signal wire to one of the UART channels through the RX port on the board. So what you do is you take a servo wire like this. You can just go to a local hobby shop and cut the wire in half, or at some point towards the end, making sure you have the right length, and you use a wire like this. So on a wire like this, the orange orange cable here is signal, the red one is positive, and the brown one is negative. I believe there's a different kind of color coding for different extensions. For example, I believe the Futaba brand servo extensions, instead of using the orange, red, and brown, they use, I believe, a white, red, and black. In that case, the white would be signal, red is of course still positive, and the black would be the negative. So the signal wire on this particular cable, I'm going to go ahead and separate these three cables. This signal wire, which is again the orange on this particular cable, would connect to the board through the RX port for one of the UART inputs. So basically, for the most part, UART 1 is reserved for communication through your USB port right here to your computer. So try to stay away from UART 1. In this particular board, I can easily see UART 3. But UART 3 is down here, and as you look through these four little slots right here, you have an RX, a TX, a 5V, and a G. So this is kind of self-explanatory. The 5V is of course the 5 volts, the G is of course the ground, TX you don't have to use, and RX is what's going to send that signal to your receiver. So again, if you're using this cable right here, the orange cable is going to go to the RX slot, the red cable is going to go to the 5V slot, and the brown cable is going to go to the G slot right there. And so of course this connector would get plugged into your receiver. And again, this will apply to Futaba S-Bus, will apply to a UDI interface like Jetty, like JR, and it will apply to Spectrum. Now, for Spectrum, there's something really special here that you have to take into consideration. Spectrum uses one of these satellite wires, as you can see here. So what you do with Spectrum is you take this wire And again, you give yourself enough slack and you cut the wire. Then you separate the ends of this wire and you splice it correctly. And in this particular situation, the orange will be your positive, the black will be your negative, and the gray will be the signal wire. So the signal wire will still plug in to the serial UART interface, which in this case is UART 3, to the RX slot right here. So it'll still solder to that. The black will still solder to the G, which stands for ground. But the difference here is you have got to be careful because you cannot solder the orange or positive to your 5V because your receiver, your satellite receiver for Spectrum cannot support 5 volts. So you have got to solder it to a port for 3.3 volts. And I don't know, once again, if the camera can capture this here, but when you look at the board, on this side of the board, the first slot right here, the first tab, correction, it's not a slot, it's a tab. The first tab right here is labeled 3.3V. So this is where you would solder on a Spectrum satellite. You would solder your orange to the 3.3, and then you would go to the UART, in this case, like I said before, I'm looking at UART 3, and then you would solder your negative, which would be black, the black cable here, to the G for ground, and the gray, which is the signal, you would solder to the RX, which is, you know, receiver technically. So to recap, for Spectrum, signal goes to RX on UART 3 in this case. It could be UART 2 depending on your particular board. The black would go to the G and the orange would go on the other side of the board right here to where it says 3.3. For example, Futaba S-Bus or Tyrannus or any other radio that uses either S-Bus or UDI or any kind of single wire interface, you would just simply do the same, but you would solder the positive to right here where it says 5V on the same UART port, I guess you could say. So, and to solder these, basically what you do is you just splice these cables, the ends of these wires, to the best you can, barely exposing a little bit of that, the wire itself, and then you just run the wire through the slot. For example, this is the positive, so I would go to 5V like this, and then you flip the board, and then you would just simply go ahead and solder from here a tiny little drop of solder on that slot until you can fill that slot, and that should take care of your soldering for these wires, and of course repeat for all 3 wires. The other thing you have got to do with your board is you have got to solder the pins. And if you watch the build video, I explained during the build video that boards come with different kinds of pins. You have these pins that are configured at a 90-degree angle, and you have these pins that are basically straight up pins. This is strictly a matter of personal preference. It depends on how you want to configure your board. But you could take your board, and if you wanted to use the straight pins, you basically would solder the pins like that. So you would add a little bit of solder to each one of these little pins right here. If you want a lower profile, which is highly recommended, and by lower profile I mean, keep in mind, if you solder straight up pins like this, when you plug in your speed controllers, you're going to be plugging like this. So if you look at this, you have a pretty high profile board, so that reduces the amount of room you have inside your frame. On the S-Racer, we provide 2 different kinds of spacers to accommodate for a taller board, but nonetheless it's much cleaner if you use these angled or 90-degree angle pins. Now your profile is relatively short here, and you plug in the wires in this fashion like this. So basically, once again, to recap, to complete your board setup, you'd have to connect your receiver to the board, which would be either a standard receiver with a standard servo wire, or it could be a Spectrum receiver like this, to where you use this type of wire and you solder these three to the board. Then you would go ahead and you would solder the pins to the board like this. One last thing that I would like to mention is PPM. PPM is basically an interface that is not widely available anymore. Most transmitter systems out there don't use PPM anymore. But if you needed to use PPM, then you still would solder the positive to the 5-volt port on your, say for example, UART interface, your negative to the G, and then you would solder your signal wire to this pin right here on this board that says PPM. That's really the only thing that changes. So the signal wire, instead of going to the RX on UART3 in this particular case scenario, would go to that PPM here. Now again, most boards are quite easy to figure out if you read the labels. This one right here is a Rev 6 from Naze, is the Acro version. Similar situation. You got your pins right here for the motors. It comes with a set of pins, of course, to install there. And then you have all these little slots on this side, and they're all properly labeled. And if you pay attention to the labeling right here, one of these right here is the PPM, like I explained before. The other one would be your serial. For example, this one here is this UART, I believe UART 3. And then you have your 5-volt right there, and you have your ground right there. So again, just make reference to the board documentation of the type of board that you're trying to use. But for the most part, the principle is still the same. You need a connection to your receiver. It's comprised of 3 different wires. One is your positive, one is your ground, one is your signal. Signal goes to serial or goes to PPM, and positive goes to 5 volts for most things and goes to 3.3 volts for Spectrum. Now we're going to talk a little bit about how to flash the software on your board. Okay, now we're going to talk a little bit about flashing the firmware on your board. So if you watched the build video for the S-Racer 207, you learned a little bit about Cleanflight configurator. So basically look at your screen for the URL, go ahead and download Cleanflight configurator. It's available for download, and it's also available as an app for Google Chrome, which makes it really easy to launch on your computer. Once you launch Cleanflight, you're going to get to the screen that you're looking at right here on my little tablet. And I apologize for not using a direct screen drop-in on the video, instead filming the screen itself. Low budget video here. But anyway, on the left hand side you'll see it says welcome, documentation and support, and it says firmware flasher. So you go to firmware flasher, and then you have to find the firmware. So I'm going to go ahead and open up my Google Chrome, and I'm going to find the firmware that I want to download. So the best thing that you can do is download something called Betaflight. Betaflight is a version of Cleanflight that was developed by the open source community under the lead of a guy called Boris B. I don't remember the URL, but I'm going to do a search for Boris B. Betaflight. It's called Betaflight. So Boris B. Betaflight download. And enter and see what we come up with. And I believe releases, there it is. So as you can see here, this is the website for Betaflight, and as of right now, Betaflight 2.9.0 is the latest release. I always stay away from the last few versions for obvious reasons. This is open source, even though it works awesome. You do not want to be there, trust me. You want to be at least 2 or 3 versions behind. I know that version 2.71, as of the making of this video, is a stable version. And again, this changes so quickly. I mean, these people release a new Betaflight version, I'm not exaggerating, literally almost every week. So by the time you watch this video, 2.71 might be like really old, I don't know. But try to go a couple, 2-3 versions behind the latest just to be safe. So when you get to this page and you find the version you want, you have to look for the actual version for the board you have. And as you can see here, you have a list of the different versions. You have, for example, Alien Flight F3, Betaflight for Dodge, Betaflight for Naze, Betaflight for SP Racing, all kinds of different files. I'm going to be updating my F3 board from Fox here. So the proper file that I need is Betaflight 2.7.1 underscore SB Racing F3.hex. So I would go ahead and download that file, which I already downloaded to my computer, and then I will go back to Cleanflight right here. And when I get to Cleanflight, I will just basically plug in my board. So I'll take my board and plug in my board through the USB port, like so, and I will hear my computer beeping telling me that it detected the board. The board will flash. And once that happens, all I have to do is push here, which is load firmware, find that file, which in this case is Betaflight SB Racing F3.hex, click open, and then push here where it says flash firmware. And as you can see here, it says flashing, and it's starting to flash the board. One thing that's important, if you cannot flash, it means you might need to short some pins on your board. And I'm going to show you that here in just a second. Let's just wait for this to finish flashing. But basically, some boards are easy to flash. You do it in the same fashion I just did it, to where you find a file, you download the hex file to your computer, you go to Cleanflight, you push on firmware flasher, load firmware, find that file, open, and then click on flash firmware, and it works. Other boards require a little bit more work, and I'm going to get to that here in a second. So for example, as you can see here, it says programming successful. So if I click on connect, it should connect to my board. Sometimes you have to unplug it and plug it back in. As you can see, it's not connecting. So what I'll do is I'll unplug it and I'll plug it back in, and then I'll click connect. It says connecting, and now I'm connected to my board. And as you can see here, it says documentation for 271, so it's telling me I'm on 2.7.1. Now what I was getting at, so I'll disconnect here, is some boards, for example, like the Nays board right here. This is a Nays revision 6. The Rev 5 is very similar, but basically these boards sometimes do not accept a firmware flash unless you short some pins. And as you can see here, these two little pads right here are labeled boot, B-O-O-T. Very hard to tell, even though I have my camera zoomed in practically all the way. But basically the way this works is you have to short these two, and while you're shorting them, so normally a paper clip works better, but I'm going to see if these scissors here, good old-fashioned scissors, can create enough continuity on these two pins. And basically while you hold those two pins together, you plug in your USB connection, then you let go of that short, and now you should be able to flash the firmware on your board. And as you can see now, my Nays revision 6 is being flashed with the 2.7.1 Betaflight version for the Nays board, and that was flawless, no issues, very easy to do. However, again, you might need to short those pins on some boards. Other boards, for example, there's a board called the Lux, L-U-X, that has a button, and you have to push and hold that button while you plug in your USB port, and that allows you to flash the firmware. But again, some boards require that, some boards don't require that, so just refer to your documentation for the board that you're trying to use for more information. So this one's flashed. Now I'm connected to my F3 board. As you can see here, this is my accelerometer, and I have this nice interface here that shows me the direction of my quad. Again, if you watch the build video, we already cover that. No need to go into detail on that. And then ports. So going back to where we were soldering the boards. So I explained to you that you have either a serial connection, which could be, for example, Futaba S-Bus, or UDI for Jetty, or JR, or even Spectrum. If you're using that serial connection, so basically any connection that you do with the exception of PPM, you have to enable the serial RX on that UART interface that you used. And as I was explaining earlier, we used UART3, or we were going to use UART3 to solder those wires. So UART3, you have to check serial RX. and that enables that serial connection. So now your board can talk to your receiver. So once you do that, you click on save and reboot, and that'll save and store that option and reboot the board. You can disconnect and reconnect to be sure that it's there, and it is. On the left hand side, we have all these options. If you go to configuration, and I cover some of these during the build video, but motor stop basically tells your board to instruct your motors to not spool up when you arm them. Some people like the motors to spool up very slowly once they're armed. Some people like the motors to stay stopped while they're armed. I prefer them stopped, so I enable that. One shot 125 is just a different kind of protocol that allows faster communication between your board and your ESC. So if your ESC support that, please use one shot. Disarm motors regardless of throttle value when arming via the aux channel. You don't have to worry about that. You can basically assign a channel to how to arm or disarm your motors, and this basically tells the system to disarm the motors regardless of what your value on the throttle is if you hit that channel to disarm. So basically, if you're familiar with RC helicopters and you have a throttle hold, this tells the system to kill your motors if you hit that channel, that throttle hold switch per se, and kill your motors. Disarm the motors after a set delay. So if your motors are armed and you don't get on the throttle to spool up, this will disarm them after 5 seconds. That's a little short. I usually increase that a little more to about 30 seconds. Minimum throttle, middle throttle, maximum throttle, minimum command. I went over that over our build video, so if you're not sure about that, please watch the build video. I explained that in depth. Basically what you want to do is you want to set your minimum at 1,000, leave your middle throttle the same, and set your maximum at 2,000. And once you do that, you save this, and then you go to the motors tab here, and you enable this function. You go full throttle, you plug in your quad, and you'll hear a series of beeps. And then once you hear that, you go to idle throttle, you'll hear another series of beeps. And at that point, you unplug your quad, and that teaches your quad what minimum and maximum throttle is. But again, make reference to the build video. If you look at our build video on YouTube, you can find exactly the spot where we talk about initial. It's actually called initial Cleanflight configuration, and then of course the BL heli setup, which is a separate topic all on its own. But going back here to the configuration, this is important here, the board and sensor alignment. So depending on how you install your board on your quad, you will see this graphical interface. If the board is pointing in that direction, you have to make sure that this is moving correctly. And as you can see here, it is. If I yaw it left, it yaws left. If I yaw it right, it yaws right. If I pitch it forward, actually no, it's incorrect. It's going backwards, as you can see here. So this is where you change it under configuration, down here under board and sensor alignment. So typically you have to alter the yaw degrees. And in this case, I believe that this requires 180, if I'm not mistaken. 180. And if I save this and reboot, and I go back to the setup portion here, then maybe that should fix the orientation issue that I had here. And again, I'm doing this based on quad facing, front part of the quad going in that direction. So we'll see what happens here. Forward, back, left and right, and yaw left, yaw right. Correct. So normally you have to mess with the yaw section here. Either 90 degrees or 180 degrees typically fixes the problem. Another thing to keep in mind here under configuration, and again I cover this during the build video, is your receiver mode. So again, if you're using Spectrum or Futaba, S-Bus or Jetty or JR or any of those, or Tyrannus, you need to select serial right here. If you're just using a PPM connection, then you would select obviously PPM. And then down below that, serial receiver provider. So Spectrum, either 1024 or 2048, or you would go to S-Bus for Futaba. I usually go to XBus underscore mode underscore B, because that's what Jetty uses, which is the same protocol as JR. VBAT is the battery voltage monitoring. We never use that. And other than that, that's about all you have to worry about on this main screen right here. There's a lot of different stuff that you can learn about Cleanflight and Betaflight. For example, you can change your system, under system configuration, you have a flight controller or flight controller loop time that changes the loop time of your flight controller. Flight controller must support it. It's a lot of different stuff here that, I mean, we could spend days talking about this stuff. I'm just trying to cover the basic things. Next, here on the left hand side is failsafe. I generally leave this alone. I do change this from land to drop. The only reason why I do that is because I disable the accelerometer, which we'll get into that here in a minute. But once you disable the accelerometer, the quad is unable to land if it loses our transmitter signal or receiver signal. Why? Because it can't level itself. So it must do something. The only thing it can do is drop. So basically a control or a crash with low throttle. So I set it to drop. See what else here? PID tuning. I talked about this during the build video in the PID tuning section here. Basically, when I did the build video, I was talking about it, and I encourage people to stay with the default PID controller, which is multi-wii rewrite. For the S Racer, I can't really give you recommended PIDs because it really depends on the motors that you're running. But for example, for my particular setup, which is Xnova 2204 motors, normally my PIDs look like this: 4.3, 4.3 for the P for roll and pitch, 8.0 for the P for yaw, and then I increase my D gain to 21 and 21 for roll and pitch. So again, default settings for the PID controller work for most people. This is something that requires some flying and some experimenting. And if you decide to make a change to any of these PIDs, make a small change first, get a feel for it, and go from there. Roll rate, pitch rate, yaw rate, we talked about that during, again, the build video. I set my roll and pitch rates to 45. I leave my yaw rate alone, and then I remove my TPA. Again, we talked about all this during the build video. The TPA is the basically changes your gains at high throttle. Then under receiver, this has all been covered. The only thing I can think of here is if you want some throttle, for example, expo, you can add expo here. For example, 0.30 expo creates an expo on your throttle curve. One thing that is important here is if you don't like this crazy curve, which makes it soft here and then makes it fast here and soft and fast, is you can change your throttle mid to 0.05, which is as far down as you can go. And then when you set your expo, it creates a very shallow line going up and down. I personally recommend that. If you want expo, set your throttle mid as low as you possibly can. I think 0.05 or even lower, like 0.03 or something like that, will allow this expo function to create a shallow curve so that it's a smooth acceleration throughout the whole range. They're not smooth and soft and smooth and soft. Then here you have your overall RC rate. I normally leave it at 1.0. You have your RC expo and your yaw expo. I normally increase my RC expo to 0.65 and I leave my yaw expo alone. And again, we talked about this section here during the build video where you set up your endpoints and your sub trims and your transmitter to match 1500 around center and then 1020 on the low side and 1980 on the high side. Once again, make reference to that video. Modes. So this is where we set up different modes for our quad. So typically the quad arms by using right yaw, right rudder on the stick on your transmitter. But if you wanted to arm it with a switch, you would select at range. You would select the switch that corresponds to that channel, say for example aux 1 or whatever. And then you would flip that switch and you would see that switch moving here, and you would select the range in which you want the quad to arm or disarm. So for example, if the switch is here in one position, and it moves here, then you would want it to arm when it gets there, not there. So that's how you would do that. The same for angle, which means self-leveling mode. Horizon, which is self-leveling mode, but with more authority. And then air mode. Air mode is basically to where you can go all the way down on your throttle and your motors are still active, and your PID control loop is also still active, so you can do aerobatics. Super Expo speeds things up, out of control. I don't personally like it. There's a lot of different options here. I mean, it's crazy. There's a lot on this Cleanflight, and again, it keeps changing. I'm just trying to walk you through the most basic things that you can do here. I never touch anything here under adjustment, servos, GPS, and really nothing else here other than motors, and we talked about that already in the built video. And then last but not least, CLI. This is the command line, I guess you could call it. And if you go to your keyboard and you type in set, S-E-T, and enter, you'll see all the different variables that are already sort of configured through this graphical user interface in a command line format. Nothing really to do here. I do disable the accelerometer, and I talked about that briefly before. And the reason why I do that is because I don't use self-leveling mode or any of those modes. To disable the accelerometer, I go basically set space ACC underscore hardware space equals none. Hit enter, and as you can see here, it says ACC hardware set to none. And another thing I do here is okay, now you can see it says fast PWM protocol set to multi-shot. And the last thing I do is I change the angle. It's a command called set space small underscore angle equals 180. And basically what that means is if you crash, it's not going to, your quad is not going to spool back up. You're not going to be able to arm your quad unless if you've exceeded a certain angle. And I don't know what the default is. It's pretty low. It's 20 or 30 degrees. Meaning if your quad crashed and it flipped and tumbled, it might not spool back up. When you do this command, small angle, set small angle to 180 degrees, then you can pretty much spool up at any time. You could be hanging off a tree and you can try to bump your throttles, arm and bump your throttle and try to get it dislodged from the tree. So it really does help a lot. So I set that command as well. Anyway, if you make any changes during the CLI interface, you just type in the word save, you click enter, and it basically saves all your settings and reboots your board. Going back to multi-shot, as we were talking before, in the very beginning here, during the configuration section of Cleanflight for Betaflight, one shot 125, I explained to you guys that this basically controls the communication speed between your board and your speed controllers. Now multi-shot takes this one step further, so it basically makes that communication even faster. Now in order to run multi-shot, which I just configured my Cleanflight, my board through Cleanflight, Betaflight, to run multi-shot, you also have to make sure your speed controllers are using multi-shot. And the way to do that is just either to flash your speed controller with multi-shot through the BL Heli interface. You can watch our built video for BL Heli interface configuration. Or the other option is just to buy a speed controller that already comes with BL Heli S, which already has multi-shot enabled. An example as of this date of BL Heli S enabled speed controller would be an XM20 from DYS, or it would be like a Lightning speed controller from Emax. But as of the making of this video, there are speed controllers that are coming out with BL Heli S and multi-shot already enabled. So If you're not using multi-shot, no need to go to the CLI and set the fast PWM brake to multi-shot like I show you. Just leave that alone, no need to worry about it. So I know this was a lot of information in a very short period, but I still hope that this was useful in sort of complementing part of the setup video that we did during the official build video for the S-Racer 207, and clarifying some doubts about how to solder your receiver, especially for those of you who are using Spectrum and other transmitters that we did not cover during the formal build video. So once again, hope this was useful, and see you at the next video.